Hi everyone, we're going to state the domain of each composite function. That means these 4 composite functions, and here are 2 functions. Basically, we need to know the domain of f of x, especially when it's as the inner function, as it would be for these two. These two, we're going to have to look at this. So basically, the domain is going to be all real numbers. However, the denominator can't equal 0. So if you set cx plus d not equal to 0, you get cx cannot equal negative d, so x cannot equal negative d over c. So x cannot be negative d over c. Alright, and for this one, since it's not a fraction, and it's also not a square root, it's just all real numbers. Now you might want to write these down because we're going to do all 4 of these compositions. So the first composition is f of g. So we have to pay attention to our inner function. In that case, it was all real numbers, so it might be easier than we think. Let's see. So we have f of g of x, which equals f of mx, which equals a times mx plus b over c times mx plus d. Now, the denominator here, if you want, you can just take away the parentheses here, but the denominator here cannot equal 0. So basically, we have cmx plus d cannot equal 0. Subtract the d. This is like a literal equation. Cannot equal negative d, so x cannot equal negative d over cm. Therefore, the domain is all real numbers. However, x cannot be negative d over cm. Next one we're going to do is g of f. Alright, so we're going to have g of ax plus b over cx plus d. Therefore, this is just going to be m times ax plus b over cx plus d. You're just going to multiply through the m in the numerator, which is going to be amx plus bm over cx plus d. Of course, our inner function is f of x, and we already knew that the denominator here cannot be 0. Therefore, our domain is like it was originally. X cannot be negative d over c. You're subtracting the d, and then you're going to divide by this c. And it can't be that. Alright? The next one is f of f. So this is going to be f composed with f of x. Now, we already know the domain for this is x cannot be negative d over c. But let's go ahead and work it out. We have f of ax plus b over cx plus d. Now we have to compose it again, so we're going to have a times ax plus b over cx plus d plus b over C times AX plus B over CX plus B D, and this is plus D. Okay, cleaning it up, we're going to get A squared X plus AB plus BCX plus BD over CX plus D. And then this is a complex rational, so we're going to have the denominator AX squared, or A squared X plus AB plus CDX plus D squared all over CX plus D. Now, we know we've got a couple things going on with this from our previous videos we watched. We already know from here that for our domain, X cannot be negative D over C. You have to put that in because that's your inner function, and we already had that. What we don't have is we have to solve for this one, because basically you can cross those out and we have our reduced equation. So we have to solve for X here. So let's do that. And what we're going to get is ACX plus BC plus CDX plus D squared cannot be 0. Now I'm going to go ahead and group my x's together, these two, and pull out the x. So this is going to be x times AC plus CD. Then we still had the plus BC plus D squared. Cannot equal 0. So I'm going to subtract these from both sides. And then I'm going to also divide both sides by AC plus CD. So this will cancel, and we have for our domain that x is all real numbers, but x cannot be negative BC plus D squared over AC plus CD. At the same time, we already had that x cannot be negative D over C. So, there you go. Now, on the next one, we have g of x. Remember, our inner function g of x is all real numbers, so I think this one's going to be easier. Let's see. So, we're going to get g of m of x, which means we're going to have m times m of x, which equals m squared x. And since this one was all real numbers, and this one is also all real numbers, our domain is any real number. And that's it. Thank you. Have a nice day. Bye-bye.